Hi, I'm Dr. Alex Krybitok, an assistant teaching professor in the Department of Chemical Engineering here at the University of Washington. And I am here in the Unit Operations Lab where I teach Unit Ops Labs 1 and 2 with Dr. Jorge Marchand. Unit Operations is where students apply theory that they learn in courses to hands-on equipment that we call units. We recently were able to do a quite large overhaul of the space because we recognized that we needed new equipment because the old equipment was somewhat broken, and we were recurrently finding that from our ABET evaluations from students, this was a high priority item where we were not serving the students well enough in their education. So when we looked around, we sort of were able to determine that what we needed for this new equipment was to be modern and still at industrial scale to prep our students for the workforce and particularly the local industries in the area. And we wanted it to be accessible to a diverse array of students and their needs. So we also wanted to keep the old distillation column in honor of Dr. John Berg, and we wanted to show the students the scale of a larger scale distillation column. So with the generous donation from the College of Engineering and a donation from an estate, we were able to get 4 new pieces of equipment. We got a tray distillation column and a reactor to still reinforce the classics in chemical engineering. We were also able to get a reactive gas liquid absorption column and a reverse osmosis unit to help train them on some more modern and particularly some local things such as reverse osmosis being used for wastewater treatment in the area. We also were able to get the floors and the ceilings and all the walls renovated and take down some of the old pieces of equipment that were no longer in use. And the space is much more bright and inviting and functional, and we're really excited to have it.
Hello, my name is Jackson Combs. I'm a second-year PhD student here at the University of Washington Chemical Engineering Department. I'm also a teaching assistant for the Unit Ops Lab, a course we have our senior undergrad students take here. And today we're going to be talking about this brand new distillation column that we recently purchased in overhauling our lab. This is a piece of equipment used in industry, typically, for separation of liquid mixtures. So we had the students model an ethanol distillation with this lab. So what we had them do was take an unknown mixture of ethanol concentration in water at around 20%, plus or minus. We had them feed the solution into a heating tank and ultimately into one of various feeding stages in this column. The liquid travels down through the column, and as it gets heated, it turns into vapor, and that vapor travels up through the column, ultimately being condensed up here where it's condensed back into liquid to flow back down through the column. We have various streams. We have a top stream and a bottom stream. Coming out of the top is your more pure ethanol-rich stream, and coming out of the bottom is your more water-rich streams. This was a great lab for our students. It's directly related to the jobs that they're going to be pursuing once they graduate our department, and it's a fundamental piece of equipment for chemical engineering. So I'm very happy to be involved in this here. So here we have a set of 4 various reactors that we have our undergrad students run in the Unit Ops Lab here at UW Chemical Engineering. The first 2 are continuous stir tank reactors, which are exactly what they sound like, tanks that are continuously stirring. We have also 2 plugged flow reactors, one with packing and one without, both having the same volume, so we can have our students ask questions like, what happens to the retention time of certain molecules when there's more or less packing, or what happens to the amount of time that these molecules are able to react with each other as we change the flow rate. As you increase flow, things are moving a lot faster and are going to exit a lot faster. As you decrease flow, things are moving a lot slower and going to have more time to interact with each other. These are some of the questions that our students are becoming familiar with using this brand new reactor setup that we have.
Hello, my name is Drew, and I'm a graduate student in chemical engineering here at the University of Washington, and a TA for the Unit Operations Lab. Today, I'll be walking you through our pilot scale gas liquid absorber, which is used to remove contaminants from a gas stream using a liquid solvent. Students can control the composition of the inlet gas stream by controlling the flow rates of air, our carrier gas, and CO2, our impurity. The gas mixture is allowed to flow into the bottom of the column and then rise through the top, through the packing material. The packing material serves to improve the contact between the gas and the liquid, which is flowed in through the top of the column in a countercurrent fashion to maximize the transfer of our CO2 impurity to our liquid stream. The liquid phase, now containing our CO2 impurity, will then flow to the bottom of the column and then out to a waste container, where the gas stream, now scrubbed of our impurity, will go through a CO2 analyzer so we can determine how much CO2 we've removed and how efficient the unit is performing. This is an extremely relevant piece of processing equipment. Is used in many industries to recover valuable chemicals and remove harmful impurities before flue gases are released into the atmosphere. And this unit gives students an opportunity to get some hands-on experience optimizing the various levers that are required for safe and effective operation.
Hi, my name is Lauren Ellis. I'm an undergraduate senior here in the Chemical Engineering Department. I work in the Rohr lab where we use heterogeneous catalysts for plastic upcycling and depolymerization. I'm here today to talk about our new reverse osmosis unit, where students are tasked with characterizing a membrane and finding the optimal operating conditions of the unit at various salt concentrations. So students will fill this tank with salt water at various concentrations. They'll pump it through this positive displacement pump up into the top of the membrane, where pressure is used to then separate water from the salt. And then you have two separate streams coming out, where you have your high saltwater concentration stream separated from your pure saltwater stream. This is especially important for students in the Seattle area to learn about, as there's been an uptake in research in advancing membrane technology. There's local companies in the area doing this, and we also have local companies focusing on water desalination, which, for example, will clean saltwater, brackish water, and turn it into drinking water that you could have at your house.
Hello, my name is Professor Jorge Marchand, and along with Professor Privatalk, I am one of the co-instructors of our Unit Operations 2 lab. Today I'm going to tell you a little bit about the future of this space and what it means for our ChemE education. As you may realize, these teaching labs are one of the most critical components of our ChemE undergraduate education. They help build a sense of ChemE identity. They reinforce the theory and concepts that students are learning in the classroom, and they better prepare our students for industry. By footprint alone, we have one of the largest ChemE education teaching labs in the country. And what I see now is this great potential for us to grow into a ChemE teaching center of excellence. We want to be a model by which other labs around the country and even the world operate. I'll start with some of the obvious changes coming in the next few years. We're going to have more students in our undergraduate program, more units in the lab, and more hands-on instruction. We are building a space for the next generation of chemical engineers. Now, our current structure is purposefully flexible and modular. We're going to be upgrading and adapting our units to meet local industry demand and also local student interest demand. In the next 6 months, we're going to be upgrading and adding in a batch distillation unit that more carefully or more closely resembles the types of units that you might see in our local spirits industry. Within the next 2 years, we're going to be adding new reactors, specifically a gas phase reactor and a biological reactor, to train students for different types of career paths. The units students train on should reflect core chemical engineering values and also be a reflection of the local growing industries that we have here in the area. Now, beyond just training the next generation of ChemE engineer or process engineer, we're also going to be training the next generation of ChemE builder, training students how to build these types of units, and also the next generation of ChemE teacher, teaching students how to teach others about chemical engineering principles using hands-on demonstrations.